can you solve this geometry challenge? Here's the question. Let's start with a parallelogram. And let's divide this parallelogram in these three triangles. Now, this segment measures 5K and this segment measures 3K. Now, let's draw a segment like this. This segment measures 3 units, this is 2 units, and this is X units. Now, the question is, what is the value of X? Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Alright, so given this parallelogram, the goal is to find the length of this segment, X. And to answer this, what we're going to do is to use the given information, for sure. So we know this segment is 5K and 3K, so the length of this parallelogram simply equal to 8K. So the bottom part simply equal to 8K. Now, our solution to this kind of question is simply solution outside the box, or outside the parallelogram rather, because this is not a box, this is a parallelogram. Now, from here, let's call this segment be equal to y. And let's set aside those colorful thing, and let's call this length be equal to a variable, and let's call this as s. Now, from here, we can see a lot of similar triangles, and here's one of them. So using AAA similarity, we can say that these two triangles are similar. So these two angles are similar, equal rather, vertical angles are congruent. This is alternate interior, and this is also alternate interior. So these three angles are equal, therefore these two triangles are similar to each other. Now, since they are similar, we can use the ratio of their corresponding sides. So we have s over 5k simply equal to the ratio of x plus y over 2 plus 3. Now let's simplify. 2 plus 3 is 5 for sure. Multiply 5 on both sides. We have s over k equals x plus y. Multiply by k on both sides. We get that s equals k multiplied by x plus y. So we can replace this s with k times x plus y. Now, another similar triangle is these two triangles. These two angles are equal for sure. These two angles are equal, and these two angles are equal. So using AAA similarity, these two triangles are similar. And using the fact that they are similar, we can use the ratio of their corresponding sides. So we have 5k over 8k plus k times x plus y equals 3 over x plus y plus 2. Now, from here, notice on the denominator, we have a common factor of k. So why not factor out k? Because we can eliminate this k on the numerator and denominator. This is just 1. Now, let's cross multiply. And what we're going to do is to multiply x plus y plus 2 with 5. So 5x plus 5y equals 10. And do the same thing to this one. 8 plus x plus y multiplied by 3. And then combine like terms, 5x and 3x, 5y and 3y. And then subtract 10 on both sides. And then divide all of this term by 2. So x plus y equals 7. Now we know x plus y equals 7. So x plus y here, we can replace this by 7. So we have this 7 times k. Now let's set aside this result. Why? Because we want the value of x. Alright? Take note of that. And now, using the last two triangles, which are similar to each other, using the same method we did a while ago, AAA similarity, these two triangles are similar. Now, using the ratio of their corresponding sides, we have 8k, 5k plus 3k over 7k equals 5 plus x over y. And this k and k cancel out. This is just 1. So we have here 8 over 7. Now cross multiply. We have 8y equals 35 minus 7x. And then rearrange some terms a little bit. We have negative 35 equals 7x minus 8y. Now let's set aside this result. And using this equation and this equation, we can now solve for the value of x. So to find the value of x, let's multiply the second equation by 8. And now take note, when we add these two equations, we eliminate positive and negative 8y. This is just 0. So this is just 21 equals 15x. And 21 is 3 times 7, 15 is 3 times 5. So divide all of this term by 3. We have 7 equals 5x. And to solve for the value of x, divide both sides by 5. So x equals 7 over 5. And this is our answer to this question. Therefore, given this figure, then the value of x in this figure simply equal to 7 over 5 units. And as always, we are done.